Hi everyone, welcome back to the channel. In today's video, we'll cover a few more examples of Solana transaction encoding, including how to fetch data accounts and filter them, as well as to encode system program instructions. These instructions require a little bit of a different tact when encoding them, so we'll go into a little bit more detail about specifically the transfer instruction, which is obviously going to be very useful for you. If you're doing Solana transactions, you'll probably do a lot of transfers, I'm guessing. This video will be a shorter video today, so let me know if you prefer this format. I'm just, because I've only recently started doing videos, I'm still trying to figure out which length of video is probably best. Most of my previous videos have been an hour long or more, some of them went over an hour. So I'm trying to kind of maybe find a middle ground. Maybe I'll need to break these videos into smaller chunks to be a little bit more digestible. But anyway, let me know if you like this format more. Before we start, same as before, same as previous videos, if you learned something new today, please consider subscribing to the channel, liking the content, and hit the notification bell so that other people can find this content as well. So, with that out of the way, let's jump right in. So let's look at how to fetch and filter Solana data accounts and how to do it in a more sort of generic way. I'll show you how I've dealt with this. I tried to kind of do, because I was finding myself repeating the same code over and over again. So I said to myself, well, no, I need to do this in a bit more generic way. So I'll show you that code in a minute. But first, let's do a little bit of theory and just show you this picture, which I really find useful. This is, I copied this straight from the Solana documentation. So it's in the, again, Solana documentation, I can't praise it high enough because it's actually pretty good. So I took this one from there. I'll see if I don't forget to put the link in the description of the video for this for the page where I took this picture and one of the other ones that I'm going to show you in the next couple of slides. But this one actually shows, in a very simple way, that there is this account info data structure, and this represents, so as you know, in Solana, everything is an account. That's something that you have to get used to. You probably already know this. And so you have, at a high level, you have executable accounts, which are basically these ones with the executable set to true, the executable field set to true. And then you have data accounts, which are the ones that have the executable set to false. And these are the ones that we're going to focus on today. So we're going to spend a lot of time talking about these data accounts. And as you can see, the data account has an owner, which is obviously the program that owns the data account. So what does this mean? For the past few videos, especially in one, I think it was like maybe my second or third video of the channel, I did spend time talking about PDAs, program-derived addresses. What does that mean? It means that a program can create data accounts, as we're showing here, and these data accounts are program-derived addresses. They reside in program-derived addresses, let's put it like that. And these are super useful, of course, because programs can create as many accounts as they like. And you can then choose in your program whether the program itself is going to pay for the account to have the rent exempt sort of sole number to prevent the account from being removed. Or if you want to have that account paid by the customer or by the user of your application, your DApp. But in any case, regardless of who pays for it, the kind of this picture, I really like it because it shows in a very simple way the relationship between executable accounts and data accounts. And as I said, I'm going to spend all of the time today talking about these data accounts. So let's talk code. So I created this fetch accounts to create, to avoid duplication of code that I was having in my DApp. And in one of my previous videos, that I've shown you the Solana smart contract, and in that video, we talked about all of the different structs in Rust that I had to create to support this DApp. And I have structs there for products, for shipping rules, for promotions, for the administrator. And as you can see here, the client side, i.e. my Dart code, my Dart Flutter code, needs to fetch these accounts. Now, funny enough, these accounts actually are generic to the program. They're not really specifically related to the user. And why am I mentioning this? I'm mentioning this because of the arguments for this fetch account. So as you can see, I pass two arguments to this fetch account. So I pass the account type, which I'll show you in a minute what that is, and I pass the user public key. Now, the user public key, when I first created this function, I was thinking that I was going to also filter by user, but in reality, I will almost 99% certain that I'm going to remove this user public key before I go to production with this, because this fetch account is really only fetching these types of accounts so far. I've not, maybe if I extend it in the future to also need the user public key, then it would remain as is. But if all continues as I think it's going to continue, I'm probably going to remove this, because really, as my comment says here, I'm not really using the user public key at all. And so because I'm fetching accounts from the program that are not related to users, then this is really redundant. But anyway, the point being, and I'm showing you obviously all of this because in case you might be interested in following kind of a similar approach in your apps. So I created this fetch account. I pass on the account type, and then the account type can be one of these different types. And then what I do is I basically go to the Solana client that I have obviously access. It's the object that gives me access to the RPC, to the Solana RPCs, RPC endpoints. And then I call this getProgramAccounts. This is a well-documented one. Again, I can put the link in the video description for the getProgramAccounts, but effectively, I might have actually put that link in my previous video. But in any case, we call this getProgramAccounts, which is directly from the Solana RPC. And as you can see, like the two sort of attributes are worth mentioning here are the program ID. So this is our Solana smart contract. So this is the program ID that is exactly where your smart contract resides. So you should know this one. So this one, in my case, it's a constant that is saved in the client-side code. And then we have obviously commitment, basically saying, only return accounts that have in the status that have been confirmed, so that they're already part of the ledger. And then filters is the really interesting one and the one that you should pay attention to. So what this is doing effectively, it's a little, for someone that had never done this before, they find this a little bit bizarre and strange, as I did when I was first starting to use this. So there is this thing called offset. So if you imagine your accounts are like a sequence of bytes, they're stored in a ledger as a sequence of bytes, so they're byte encoded. Remember, this is the so-called portion coding, is all a binary format. And what this means is effectively every account at the start of it has an account discriminator. I touched briefly on this on my last video. Check it out if you want to see more details on that. But think of it as the account type, like it's the data type. So it could be a product, it could be a shipping cost rule, could be a promotion, an admin, etc., etc., etc. So what I'm trying to do here is saying, okay, so if I get an account type, so say that I'm looking for accounts of type product. So I want to fetch all the products. So I would say, give me all the products in the argument. And then here I'm saying, because I know, and this is like a critical piece of information that you really need to know. I'll show you the code in a minute, what this compute discriminator is doing. But, and this is information that I wish I had when I first started coding in Solana, and it was really, really difficult to find this online because there isn't much documentation talking about this. Again, I suspect this is because most of the people that fetch information from Solana, they do it using JavaScript, and I suspect the JavaScript libraries don't expose you to having to know all of these things. But anyway, correct me if I'm wrong in the comment section below. So if you know otherwise, then let me know. Eventually, I'll have to familiarize myself as well with the JavaScript side of doing this. But so far in Dart, it's painful because you have to do these things. So, or maybe not. Maybe in JavaScript, you also have to use this because potentially the RPC forces you to know this. But in any case, the RPC method, the getProgramAccounts endpoint. But in any case, all you need to know is that the first 8 bytes is the account type. And what I'm saying here is start at offset 0. So start at the very beginning of the representation of the data, and compare, starting at the beginning, compare those first 8 bytes with that correspond, so that the first 8 bytes should correspond to the byte representation of the type. So let's first start looking at the account type. So how did I represent the account type in my case? Again, showing you this, you can represent it in whichever way you want. You could use magic strings, simple strings of text if you like, but I wanted to use enums because it's less prone to error, let's put it like that. But so I created an enumerated type with all the accounts that I need to search for: product, shipping cost rule, promotion, and admin. And then I extended that type by basically saying, if I say account type dot product, return to me the string product. Same thing for shipping cost rule and so on. And now the really important thing for you to remember is that these names here, these strings, they're not just accidentally there just because I randomly decided to call it that. These strings match exactly the names of the structs in Rust, in the Solana program. So see, there is a parallel here. So the data type name that I gave it in Rust is the name that you see here. Remember that. Okay, so that's the account type. The compute discriminator, which is being called here. So again, the filter, what it does is it compares the bytes of the accounts that it fetches from getProgramAccounts. Again, starting in offset 0, starting in the very beginning of that sequence of bytes, and says, please return to me all the accounts that actually match this type. And the type has to be converted into a byte sequence. So this is what this compute discriminator is doing. It gets the account type as a string, so it's the account type dot name. Again, remember that dot name basically converts it into that string that I just told you about. And then what it does is it hashes with chat256. It hashes the following string, and again, this took me an hour possibly of struggling with trial and error to find exactly how. I finally found deep in the weeds online in some forum somewhere, someone mentioned that this is how they actually do the account type encoding. Um, so, so it's account colon and then the string that is basically the type name that you gave in your Rust program. Got it? Just remember this. Account colon product, for example, or account colon promotion, right? That's the name. This is the name in your Rust program of the type that you're looking for. And this is always the same, account colon, constant. So when you do this, so you hash it first, and then you basically return a sequence of bytes that is basically just the first 8 bytes of that hashed value. Okay? So when you do this, you return this, and then that is what you give here for the comparison. So your bytes are the value that you're going to compare against. And so this getProgramAccount effectively goes and says, okay, let me look at all the data accounts that belong to this program, to this smart contract. And now let me look for the accounts that match this account type, which is encoded with these bytes, which is what this compute discriminator is actually doing. Again, this is a gold nugget that I'm giving you that you'll probably don't see many places giving you this information. So good that I gave you that, because that saves you a lot of time if you don't know how to do this. Right, next one. Next one is, so this is basically the continuation of fetch accounts. So it starts by fetching the accounts from the Solana RPC. And then once it gets the response back, you need to decode the response. So as you can see, the response, I decode it in this way. So I know that it's this binary account data type. And then I effectively take the data attribute. So this is like a blob of, it's an object that contains several fields. One of the fields is the data field. That's the one that we're interested in. So I extract that, and now I call this decode data function, which is a function that I created, and I pass on the data, the binary data that I got from the Solana RPC. So you might be wondering what that decode data does, and this is the code for the decode data. So what it does is, again, look at what I'm doing here. Again, same as before, we know that the first 8 bytes are the account discriminator or the account type, if that's a better way to describe it. I take those first 8 bytes, so I know that this is the account type. And then I take the trimmed data, i.e. the rest of the data without those first 8 bytes. And when we deserialize this should be deserialized into the type, i.e. the product, the shipping cost rule, the promotion, the admin, to the type that we care about, right? So that's the trimmed data here represents the actual data that is of interest to us. So as you can see, I created this this map that basically maps the type to the sort of lambda function, to the function that deserializes that data. So this is what I'm doing here. So I'm going for, for every single different type that we have, I check that the first, so if the first 8 bytes, which is what we extracted from the data that we receive here, so if the first 8 bytes are equal to one of these, product, shipping cost rule, blah, 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 then return the deserialized data, right? And what is that? It's basically saying that it's the calling this function. So say that it was a product that I was looking for, right? So in that case, what I'm saying here is if the data contains products, because that's what I searched for when I looked when I went to the RPC looking for the account data, that data should contain products. So what it does is it basically goes in here and says, does it equal? So when entry equals product, it goes and says, do the first 8 bytes of the data that we received from the RPC, because remember the RPC returns an array, like a list of all the accounts. So this means that I'm calling this, as you can see here, I'm calling the decode data for all the accounts that returned. So in my case, I have like 2 products, so it returns 2 accounts. And then for each of those 2 accounts, it calls this decode data. And then, it asks the same question for these 2. So, does the first 8 bytes of the first account that got returned equal product? If yes, deserialize it by calling products received from Borscht. So it's basically doing the deserialization. And basically what this does is it creates a product object, which I have defined in my Dart code. And you guessed that this product object corresponds to the product struct that I have on my Solana smart contract. All makes sense. So that's compute discriminator. And so I hope this gave you a good sort of grounding for how you fetch different account types in Solana. And now let's switch gears to how do we do system program instructions. So how do we call system program instructions? And more specifically, we'll be looking at the transfer instructions. So how do I transfer SOL, for example, from account A to account B? So same as before, let's look a little bit about, take a step back, look at the more generic sort of picture. Again, this came from the Solana documentation. So I'll stick the link down below in the video description for this one as well. I believe it might be in the same, if it's not in the same page, it's in the same place that you got the other picture. And as you can see, so inside of a transaction, you have instructions. One of those instructions can be a SOL transfer instruction. You'll see that in a minute. And yeah, you have it's part of the system program. You specify obviously the transfer amount of SOL that you're in line ports that you're transferring from account A to account B, and then you have the accounts. So you have your account from and your account to. As you will be able to see here, there is again, I mentioned this in my previous video, all of these accounts, you always have to say whether the account is the signer or not. So because this is the from address, that means that its a signer is true. So it's the person that is the entity that is sending the SOL needs to sign the transaction because the SOL belongs to them, so they need to approve it effectively. And then is writable? Yes, of course, because I'm changing the amount of SOL on that account, so yes, it's writable. And same as the to address, it's writable because I'm increasing the SOL amount, but it's not a signer. Of course not, because the receiver of the SOL doesn't need to sign the transaction. So very simple, very elegant way of explaining or depicting a Solana transaction. So let's look at the code now. So let's talk about this first one here. So I took this from my purchase order function. This is just a tiny little snippet of a very sizable function. And in that function, this is where I build the transaction. So I create a Solana Web3 transaction object, V0 transaction object. And as you can see here, a few elements here that are interesting. So you have the payer. So who's going to pay for the transaction? In this case, it's the user. So it's the front-end customer user of the DApp, again, of my wine selling platform, of my e-commerce platform. So that's the payer. And then you have the instructions. Note the difference. I think this is the first time in my videos that I'm showing you a transaction that actually is comprised of more than just one instruction. In all my previous examples, I think in the user profile one that I've shown you last video, I had only one instruction. For the vast majority of times, for example, I'll give you another example. When the user first places a purchase order, the I need to register their delivery address. And so there is a transaction there to update their delivery address in an encrypted way, of course, in the Solana blockchain. And that only requires an update instruction, which basically means I'm just following the one instruction in my Solana smart contract. So again, this instructions array would be just the one instruction. And for the vast majority of interactions that I've had so far in my DApp, in the DApp that I've been building, and the one that I'm sharing this journey with you, the vast majority of my Solana transactions are just the one instruction. But in this case, for example, I'm doing two instructions. Why? So I need to do a transfer instruction. So this is the final one where the user confirms that they're happy with the amount that is being displayed to them, that they want to do the purchase of, in this case, of the bottles of wine. So the user basically clicks the button to purchase. And then in this case, they're approving the transfer instruction of whichever amount, let's say 0.5 SOL, whatever the number might be. And then the purchase order instruction. Now this is another one, which basically, I'm not going to go into the detail of what that is, but it's basically a metadata associated with the transfer instruction. So it has stuff like what user is this transfer instruction, what user bought what. So it has the list of products that they bought, the quantities, it has, obviously because it has their public key, I can relate that to the shipping address, it has all of this information. So this information is basically a PDA that belongs, a program derived address that belongs to the Solana smart contract. And it's associated with this transfer instruction. Now, one of the things I believe I did mention this in one of my past videos, these transactions are like in a database transaction, in typical relational sort of database transaction, for example, that most of you must be familiar with. Like in a transaction, the whole transaction only succeeds if both of these instructions succeed. If one of them fails, the whole transaction fails, right? And therefore, like for instance, if this transfer fails, that one doesn't take place, and if this one fails, that one is, I believe, reverted. I'll check that, but I'm almost certain that that's the case. And in which case you should interpret this as an atomic sort of transaction that is comprised of two instructions. So I know for a fact that if this was created, that one had to take place. That much is certain, right? So this is an interesting property that you should all be aware of, because it's a guarantee that things are coherent in that way. I don't want to say this if that didn't take place, of course. And yeah, that's how you should interpret it. The other thing that is here is the recent block hash. We talked about this in the previous video. If you want more detail on that, please watch the previous video. And so, what else do I have here? Right, so This transfer instruction that you see here is what I want to talk about, because we talked about how to encode transactions or instructions transactions for our specific smart contract, but we didn't talk about how do we call system program instructions, like the transfer instruction. And this is what we're doing here. So I created this in my DApp, in the Dart code. I created this create transfer instruction. I'll show you the code of that in a minute, but it receives two public keys and an amount, right? So it makes sense. If you're transferring, you need the from, like what address are we transferring the SOL from, and what address we are transferring the SOL to the destination address, and of course the LAN ports, i.e. the SOL. So how much we're transferring. In this case, it would be for the total of the purchase order. So this is the code of the create transfer instruction that you just saw that I called there in my purchase order sort of function. So the create transfer instruction, as you can see, these are the inputs, the arguments. It creates. So what does this? What is this going to? It's going to look very similar to a typical instruction that we call from our own contract, but it has a few things that I had to define in order to call these system program instructions in a way that works. But the similarities are this. So when you create the transaction instruction object, which we return, and then you add to the other one that has the metadata, which is the one that we already saw how to create, it has, when it gets created, it has the keys. So the keys are this. So they are effectively the different accounts that the instruction is going to need to operate on. In this case, there are only two accounts that it needs to operate on. It's the from account, which is the signer and writable from account. And it's the writable, which is the destination account that is going to receive the SOL. So that's understood what that is. Then you have the LAN ports data. So this is the how much SOL we're transferring from and to. So this is the LAN ports. As you can see here, please note how I'm encoding in binary format the LAN ports. I don't remember if I had to create this U64, but I'm going to, in my next video, I'll talk about this at the end of the video. I'm going to talk about data types in more detail. So if this is one of those, I'll definitely talk about that in the next video. I'm just not, I don't remember now. I've done this quite a few months back. So now, yes, so this is basically encoding the data element in bytes, i.e. the amount of SOL. And right, so this is the really important part here, because these are this is very similar to the way that we call our own smart contract instructions. So in the end, as you can see here, you have the sequence of bytes that is comprised of the instruction data, which is that, which I'm going to show you in a few seconds. And then you have the LAN port data. The instruction data you should think of as what's the instruction name that I'm calling. So, for instance, in my last video, I've shown you, for example, how to call add customer. So we had the add customer method that I was calling. So the method data, I think I called it in that video, was basically the method name, which is add underscore customer, if I'm recalling correctly, and then it has the arguments for that method. So and then you merge the bytes from one with the other, so you merge this sequence of bytes together, and you have the full sequence of bytes of what you're calling. In this case, it's kind of similar, right? Because you're saying what is the instruction name that you're calling, which is this element here. This name is actually I should have named it something else. But instruction data is basically the instruction name that you're calling, and then the lampports data is the arguments. Effectively, it's like how many SOL that am I transferring, and that's ending up here, which is these two concatenated together. So let's look at the system instructions. So this is really critical, that the transfer instruction, as you can see, I created this enumerated type that has all of these instructions. Transfer is number 2. So so this is information you really do need to know. What each instruction corresponds to, so that you can create the enumerated type that has these things. Now, the reason I believe I had a little bit more trouble with this is, again, as I keep saying, I wasn't a good student, and I didn't go with the standard JavaScript client code. I went with Dart, and this is why I'm having all of this trouble, because I think unless there is a library out there or a package out there that has all of these things already predefined and I don't need to worry about it, then apologies, I should have found it. But I did search for one, and this was, after spending probably a few hours worth of banging my head against the wall, this is exactly what I found. So I found the definition, I think it was on GitHub somewhere, of these, how they define these different system instructions, like what numbers correspond to what instruction. As you can see, there is this create and assign and transfer. I don't even know what all of these do, but effectively I saw, aha, transfer, that's the one that I want. But I passed all the other ones because I found, oh, this is useful. Maybe, if in the future I need to call one of these other ones, at least they're already defined there. But effectively, this is like the key piece of information of all of this that you need to take away is, if you need to do a system program transfer in Dart, obviously JavaScript might be super easy and super simple, because I think what they do, if I remember correctly, with JavaScript, the reason it's so easy and you don't need to worry about any of this is because they already have object types for all of these things. So it's almost like, oh, I need to do a transfer. Okay, create object called transfer, or transfer instruction, or I don't remember now the name, but you get the picture, right? So there are objects already, nice objects that hide away all of these things. You don't need to worry about any of this. You just say, okay, it's the transfer instruction from to amount. That's it, done. You don't need to create all of this, right? So your life will be a lot easier if you're using one of the clients that already has a lot of good support for that client, which is JavaScript. In this case, I chose Dart, and that's why it's painful, but at least I have the cross-platform, runs everywhere benefit, and that's why I chose it. But for those of you that only use web, then forget about all this and just do JavaScript libraries. It's much easier. But it's nice to know, I think, and this is one of the things that I want you to take away from this. This is not like, if you're learning this for the first time, again, looking at Dart code in this case, it's good to know that under the hood, this is how these things are defined. If you in the future have some problems in JavaScript, you know that this is how it works under the hood. So you can maybe troubleshoot your issues a lot quicker because you know these things. Anyway, I'm rambling a little bit, so let's continue. So now you know how I define system instruction. And here it's also important to see how this encode instruction is actually working. So it gets this system instruction enumerated type as an argument, and it returns the sequence of bytes of that enumerated type. Yeah, not much else to say, but this is, all of these is byte encoded, and that's why you need to do this. Right, we got to the end of the video. So conclusion, so we've covered the core aspects of Solana transaction encoding, with particular focus, of course, on how to filter for different types of Solana accounts or data accounts, let's put it like that. And for a Solana program, we also looked at how to call system program instructions, in this specific case for the transfer instruction. And we went through the details and the different types of data structures that I had to create in Dart in order to make this work. Because again, as I said, I couldn't find a package that already had these nice objects that I could use out of the box without having to define all of these types. So yeah, so looking ahead, so in the next video, I'll dive more into sort of more complex non-standard data types for transaction encoding. We will specifically address some limitations in JavaScript types and how I basically extended the behavior of the Borscht package to add support for non-standard data types. So I hope you enjoyed this. Thank you for following along. I hope that this presentation basically gave you a clearer understanding of more detailed examples of how to encode Solana transactions using Dart, of course. Even if you're using, as I said, even if you're using JavaScript or any other language for sort of client-side DApp development, most of what you learned here, apart from obviously from the syntax, is I think useful stuff to know. As I stated in some of my last videos, I keep saying this, but it's true. A lot of this, I wish I, when I first started my programming journey with Solana, specifically, all of these things like the compute discriminator, knowing that it's like a count colon and then the precise name of the Rust program struct. That like it took me so long to find that. Other things like how you filter the different account types, and it's like the first 8 bytes. Again, a lot of these things, they may be mentioned in the documentation, but it's not like it's deep in the weeds somewhere, sometimes not official documentation. This is where I found some of these things. So I hope you take a lot of value from this video because of that. So you don't have to waste as much time as I did. And as always, feel free to reach out with any questions or feedback in the comments below. And as I said in the beginning, if you found this useful, please drop a like. A subscribe would be excellent. And stay tuned for more updates. And don't forget that you should always stay empowered and decentralized. Thank you very much. Goodbye.